Okay, for the second part of this session, we're going to look at harmonics. Standing waves are two transverse waves that interfere with each other. They form one wave, as you can see from these pictures. These are all examples of standing waves. The key is they have to have the same amplitude, the same wavelength, but opposite directions. So one's going this way, one's going this way. The things we will need to label: the nodes and antinodes. We know that nodes are locations where the wave crosses the nodal line, and antinodes are the opposites. So if you're looking at with this, the node is stationary, the antinode is the largest amplitude. So node, 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 node. Antinode, antinode, antinode. So you could look at these. On this one, you'd say there's 1, 2, 3, 4 nodes and 3 antinodes. You will need to count these. How we count standing waves, or how we describe them, is by the harmonic number. You can have the first harmonic, which is the fundamental. The second, notice there are 2 antinodes, which makes it the second harmonic. The third harmonic, there are 3 antinodes. So if you can count the antinodes, you can figure out which harmonic you are in. Here's an equation you'll need to calculate the frequency. You have the harmonic frequency equals fundamental times the harmonic number. Some examples. This one's asking for the frequency of the 4th harmonic of a 6 Hz fundamental. So you have your equation. Frequency of the harmonic equals the fundamental times the harmonic number. So we need F sub H equals the fundamental 6 Hz, so that's 6 times the 4th harmonic, so 4. So 6 times 4. And you'll get the answer is 24 Hz. Try this second one. See if you get the same answer, 10 Hz. You're looking for the fundamental frequency in that second one. Here's some examples in the physics book you can look at if you would like more practice in addition to the worksheet packet that you have. We are also going to look at wave interaction. Interference, when 2 waves meet or overlap. There's constructive. Think about it in this way. Construction, you build. So the amplitude is going to increase. It's going to be this amplitude plus this amplitude. It will increase. The result is always the sum of the amplitudes. Know that phrase. The result is the sum of the amplitudes. Destructive, easy to remember. Destroy, destruct, break down. In this case, they meet out phase. So you have a crest meeting a trough. When these 2 amplitudes are exactly the same, again, you take the sum of the amplitudes. When they're the same, you get 0 wave. It cancels out. Becomes 0. Destructive, they cancel. Constructive, they build up. Reflection. At this point, we need to know it's the bouncing back of a wave. We'll get more into that when we talk about light. Diffraction. Spread out past the edge. We'll talk about that in an activity in class. Refraction, again, we'll get more into with light. It's the bending of a wave. The bending of a wave. And we will talk more about that with light in the next topic. Do not forget to go take your quiz on the Moodle site, which will be due March 17th by 9 a.m.